Good afternoon. My name is Ben Librand. I'm from the Department of Geography at Texas A&M University, and I'll be discussing the three-dimensional interior routing of Texas A&M's Liberal Arts Building. Contributions by Jacob Blankenship, Samuel West, Blaine Stevens, Jake Meador, Edgar Hernandez, Jinwoo Park, and Dr. Daniel Goldberg. Finding rooms inside of unfamiliar buildings can be stressful. Buildings have unique layouts, there's different accessibility means, such as stairs and elevators. And since we live in a 3D world, we felt that representing this information would be best done through a 3D map. And so this would allow for people to better orient themselves inside of buildings and provide them with navigational routes through the building. Our goal was to solve these routing issues by using 3D methods and using the Liberal Arts Building as our test subject. And we had two different reasons in mind. The first would be for normal use for students who are new to campus or unfamiliar with the location, and also for emergency evacuation purposes and support of first responders. And when making this 3D map, we wanted to incorporate into the already made Aggie map for public use. The motivation behind the project was that this would be the first 3D interior routing of Texas A&M University's building. And since 3D better represents reality, we felt that it would be appropriate for new visitors and new students who are unfamiliar with the location. Our approach is to ensure proper routing, and in doing so, we needed to make sure that we were starting off with the most accurate data that we could gather. And we felt that CAD files would be the most accurate. And once we generated all the data, we hosted it on Texas A&M's FCore server and ArcGIS Online's portal. And this helped us to call the different layers and different information that we needed so that we could integrate it into the Aggie map. The different methods that we used, like I said, we started off with CAD files. Once we had the CAD files, we geo-referenced them, made sure that they were accurate in the location on the Earth, and then we started to digitize each room individually, collecting as much information on the room as we could, and compiling an attribute table consisting of all of that information that we could get. Once we had each level made, we assigned all the attributes their accurate Z value, which is the elevation for each point. And so that allowed us to bring it into ArcGIS Pro and display it in a 3D model and allow us to generate the network. And the network allowed us to make the route possible within the building. So we could select an exit and a point within the building, and that would generate the most efficient route through the building. And then once we had the network made, we then used a series of different languages such as JavaScript with Esri's Dojos, HTML, and CSS to make the web map possible. So we had network data, we had the 3D model data, and both of those combined allowed us to bring it into a web map and generate the routes within the buildings. So the different data consisted of room point locations, exit points, aisle lines, stairs and elevator lines, and room polygons. And basically the aisle lines are what connected everything together and made the network possible. So it connected the exit points with the hallway lines and the room points, and at each of those connections, different nodes were put there so that the connectivity through the building was accurate and it would allow us to provide a user with the most efficient route through the building. And in the process, we went through a lot of accuracy assessment issues, such as going through and cleaning up the aisles, making sure we had the most efficient route through the building. We went through that floor by floor, making sure that everything was accurate and consistent. And then once we were done with that, we went into the building and ground truthed the data. So whenever we generated a route, we would walk the route through the building and make sure that that route was accurate and it would provide the user navigation to their desired endpoint. So these are our results, and I have a demonstration of how it all works. So it opens just like a normal website does. And once it opens, you'll see that the liberal arts building is in the center of the display. And in the top right corner, we have different toggles that the user can turn on and off depending on how much information they want displayed. So you can have everything turned on, or you can have everything turned off and only displaying the route. And that is completely dependent on the user and how much information they want displayed to them. So you can see that this is the entire Texas A&M campus. And when you zoom in, you can focus on just the liberal arts building. You can turn the trees off, you can turn the mesh off, you can turn on and off the stairs, the elevators, and you can turn on all the floors if you just want the route shown. So when you have the mesh turned off, you can click on individual rooms inside of the building, and it gives you different attributes such as the room number, room name, etc. And if you want to look up a room and get a route towards it, you go up to the top left corner and you can type in a room number, hit submit, and it will generate the route. And if you notice, if you type in a room number that is on one of the lower floors, like the first, second, third, or fourth, the top levels will not show, such as the fourth and the fifth, allowing you to see inside the building. We also made it possible to where the program will not fail silently. So if you type in a room number that doesn't exist, we'll simply tell you it does not exist and allow you to type in a different number. So you can rotate around, you get different aspects on where the route is. And you can rotate up to the top and see that the route is actually going through the elevator. We're very happy with the results, and we think that it turned out really well. So in conclusion, we provided a 3D interior route method for buildings, especially the liberal arts building on campus. We integrated into the Aggie map. We discovered new ways to interact with 3D data using HTML and JavaScript. We found that you do not have to generate a separate portal for ArcGIS Online. You can simply upload your data to the website, and you can call those different layers using JavaScript and query for the particular information that you want. And you can call that and put it straight into your website. The future of the project will lie with integrating it to the ADA routing map that already exists, allowing for a person to start anywhere on campus and be navigated to a particular building with turn-by-turn directions. And once they get to the building, they will be able to be routed through that building to a particular room, making the map fully connected and fully functional that could potentially replace the 2D Aggie map. And this also opens up the door for different applications, such as different events on campus, allowing people who are unfamiliar with the campus to be more efficiently navigated through the campus and making their whole interaction with Texas A&M more enjoyable. So thank you for listening, and if you have any questions, please let me know.